Hello 10th class students, as we have completed 4 chapters, now I am going to start atomic structure. So before starting the atomic structure officially of 10th class, what you have to do is you have to go through with the textbook of 9th, which includes atoms and molecules in it. So here I am giving you a few videos of basics which you have to watch before I start the expression for chapter atomic structure or structure of an atom. This is a very important chapter. Entire chemistry starts from here. So the foundation which you need for chemistry is like starting from this particular chapter. So go through with the topics of ninth first, read the textbook and watch the videos. Then like after 3 or 4 videos I am going to start the explanation for a structure of an atom.
Hello friends, this video on atom and molecules part 9 is brought to you by examfear.com. No more fear from exam. See, in the real world we have so many compounds. Okay, and the compounds are like water. Water is a compound. Or let's suppose ammonia or sulfuric acid. Some common compound which we use, I am just writing it down. Or methane gas. So these compounds, there has to be some way to write this in the chemical world, because water consists of, we know, hydrogen and oxygen. Ammonia consists of nitrogen, hydrogen. Sulfuric acid consists of hydrogen, sulfur, oxygen. Methane consists of carbon and hydrogen, right? And water has 2 hydrogen, 1 oxygen. Ammonia has 1 nitrogen, 3 hydrogen. Right? Sulfuric acid has 2 hydrogen, 1 sulfur and 4 oxygen. Methane has 1 carbon and 4 hydrogen. Right? So we know all this. We know the name, we know that compound has these many atoms. So there has to be some way to write it, to understand this water easily, or to write a chemical reaction. There has to be some way to represent this water in a better form. So to understand this water in better form, we have to understand a concept called valency. For example, water is represented as H2O, ammonia as NH3, sulfuric acid as H2SO4, and methane as CH4. So looking at the formula, you can actually tell that one water molecule has 2 hydrogen and 1 oxygen. One ammonia has 1 nitrogen, 3 hydrogen. One sulfuric acid molecule has 2 hydrogen, 1 sulfur and 4 oxygen atoms. One methane molecule has 1 carbon and 4 hydrogen atoms. Pretty easy, right? See, everybody has a name. You have a name, your school has a name, everything has a name. Name is just to recognize that. If I say that this video is from Exam Fear has a name. You can make out, okay, this video is from Exam Fear. This is a brand. Similarly, you must be having some name. Rohit, Shobhit, so many names. You must be having Tom, John, so many names. So these water molecules or these compounds also have a name, and these names are water, ammonia, sulfuric acid. And chemical representation is H2O, NH3, H2O4, CH4, like that. Now we have to understand how to write this. Why water molecule is H2O? Why it is not OH2? Right? If it has only 1 oxygen and 2 hydrogen, we can even write it like this, right? So why it is that these names or these chemical formula is used to represent water? Why H2O is used to represent water? Why not OH2? So we'll understand that. To understand that, let's understand the concept of valency. See, valency is nothing but combining capacity of an element. Write this as combining capacity of element. Right? This is valency. Okay. So the combining capacity or the combining power of an element is called valency. Or you can visualize this as the hands of atom. For example, there is one atom here, oxygen. It has two hands. And from these two hands, it can pluck one hydrogen each. So you'll get water. See, human has two hands. Octopus has 8 hands. Right? Or snake, there is no hand in the snake. Similarly, you can visualize these valency as of now as hands of a particular atom, right? Sulfur has a bigger hand, HCl, carbon dioxide. So carbon dioxide has 4 hands actually. 2 hands, with 2 hands it will bind oxygen, and other 2 hands it will bind other oxygen. Or if it has to bind hydrogen, with all the 4 hands it will bind one hydrogen each. You will understand these things in detail in the higher classes. For this class, just understand that, or just visualize valency as the hands of atoms. Right? Some element shows more than one valency. For example, iron. Iron sometimes binds with 2 chlorine. Sometimes iron binds with 3 chlorine. So these are different cases. And we'll explain these things in the higher classes based on the stability. So the higher classes will talk about stability of a particular atom. I think in the next chapter when we discuss more about atom, I'll try to touch upon that. But in the higher classes, you'll understand these in more detail, why iron exists as FeCl2 and FeCl3 both. Or iron has 2 hands and 3 bands together. Right? So this is all about chemical formula. Chemical formula is a formula to represent a particular chemical. For example, water is represented as H2O, ammonia as NH3, sulfuric acid as H2SO4, methane as CH4, hydrochloric acid as HCl. It is a way to represent the chemical compound. It is very useful in the case of chemical reaction. For example, you can say that C plus O2 is CO2. You can write a balanced chemical reaction. Okay. So there has to be some rules to write chemical formula. Let's understand the rules to write chemical formula. For example, when you write A, B, C, D, there is a rule. A has to be like this, B has to be like this. And with these letters actually you form words and then sentence, and the whole English grammar is based on these 26 letters. So here also we have some rules to write chemical formula. The first one is the valency or the charge on ion must be balanced. It will be right here. The valency, there is a combining capacity we have told, or charge on ion must be balanced. Let me write it first and then we'll see what it is. Right? Now, as I told, why H2O, why not OH2? Right? So there is a rule for that. So if the compound has metal and non-metal both, then metal symbol is written first. Metal symbol written first. Written first if it has both metal and non-metal. Example, calcium oxide. We don't write CO, we don't write OCA. We first write calcium then oxide. Sodium chloride. We don't write ClNa, we write NaCl. Sodium is metal, chlorine is non-metal. Right? Copper oxide. First copper, then oxygen. Oxygen is non-metal, copper is metal. Right? Metal will be on the left hand side, then non-metal. Metal, non-metal. When you talk about metal, non-metal, typically we first say metal and then non-metal. Similarly here also first metal and then non-metal. Okay. Third is sometimes the compound is formed with polyatomic ion. In that case, the ion is enclosed in a bracket. Before you write the number to indicate the ratio. For example, I'll write this off. This is only in case of polyatomic ion. So in this case, it has to be written in bracket. Okay. Any example you think for this? So for example, CaOH2 Al2SO43. So in this case, if you see, this OH is a polyatomic ion, SO4 is a polyatomic ion. We'll talk about this. We'll see examples, right? So this is a polyatomic ion, so we have put the braces here. So here actually, when you talk about the first formula, SO4 will have a charge of -2, right? And aluminium will have a charge of +3. So if you see the net charge on the left hand side of the metal will be +3 into 2 is +6. And similarly, the net charge on the right hand side non-metal part, iron part, will be -2 into 3 is -6. So the net charge is same, and that is the first rule, and that's why we have this formula. Second rule, metal is written first. So if you see here, aluminium is written first, here calcium is written first. And since there is polyatomic ion, this whole polyatomic ion is put in braces. Okay. So 3 rules. Remember, the valency, the charge of the ion must be balanced. That is the first rule. For example, you write the formula of HCl. Let's suppose hydrogen has the charge of +1, Cl has the charge of -1. So you put like this, 1 and 1. So the formula will be HCl. If you make water, hydrogen has a charge of +1, oxygen has a charge of -2. Put like this, -2 comes here, +1 comes here without any charge. And formula you get is H, 2 is here, 2, then O. Similarly with H2S, hydrogen, sulfur, +1 charge, -2 charge, -2 comes here, +1 comes here. So the formula you get is H2 and then S. There are so many examples. Let's take out MgCl2. So Mg has the charge of +2, Cl has the charge of -1. It goes here, it comes here, you get MgCl2. So in all this case, if you see, the valency is balanced. To balance the valency, what we are doing is, there is a -2 charge, so we will take double of this. This is the +1 charge, we will take only single. Okay. A good example is aluminium, oxygen. Aluminium has a charge of +3, oxygen has charge of -2. You put 2 here, you put 3 here. What you get is Al2O3. This is the compound you get. So in this case, if you see, the charge is balanced. So if you see, the aluminium charge was +3, oxygen was -2. On the left hand side, the charge is +3 into 2 is +6, and right hand side you get -2 into 3 is -6. So +6 and -6, overall it is 0. In all these cases, if you see, the metal is written first. Hydrogen is both metal and non-metal, I'm not sure, but the non-metallic character of calcium and oxygen is more than hydrogen, so hydrogen is written first. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attend free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on Atom and Molecules part 10 is brought to you by examfear.com. No more fear from exam. So let's take some simple compounds. We'll use the formulas which rules we just told you, 3 rules. First one is the charge is balanced and the metal is written first. In case of polyatomic ion, it is enclosed in the braces. Okay. Let's first write some chemical formula for simple compound. See, simple compounds can be made of two or different elements. They are called binary compounds actually. Okay. For example, NaCl, HCl, okay, H2O, H2S. These are all simple compounds. CCl4, MgCl2, calcium oxide, Al2O3. All these are simple compounds. You see here, they are made of only two atoms: NaCl, HCl, HO, HS, CCl, MgCl, CaO, AlO. Okay, let's write the formulas for this. NaCl, plus charge, minus charge, 1 1. So this becomes NaCl. Pretty easy. So in this case, if you see the first rule, the charge is balanced, yes. Metal is written first, yes. This is not polyatomic, so we'll not go for third rule for all these. We'll go for only first two rules. At least for this set. Let's write for HCl. It's plus 1, minus 1. You charge balance, you get HCl. H2O, plus 1, minus 2. You get 2 here, you get 1 here. You get H2O. Similarly, H2S, plus 1, minus 2. What you get is H2S. CCl4, CCl, minus 1, plus 1. Right? Sorry, carbon is 4. So this becomes 1, this becomes 4. So what you get is CCl4. Let's try for others. MgCl. Magnesium charge is 2, chlorine charge is 1. You get 1 here, you get 2 here, you get MgCl2. Calcium oxide. Calcium charge is plus 2. This is minus 2. This is 2. This is 2. This becomes Ca2O2. 2 we can actually take cancel. It becomes CaO. Al2O3. This is aluminium. This is oxygen. Aluminium plus 3 charge. Oxygen minus 2 charge. This becomes 2. This becomes 3. You get Al2O3. So that's how you write simple compounds. Okay. Pretty easy. You can just try. It's very easy actually. Let's take some more questions now. Formula of carbon tetrachloride, we just saw it was CCl4. Just now we have seen that. So there's a carbon with a plus 4 charge, with the minus 1 charge. So this goes like this. This one becomes CCl4. Magnesium chloride also we saw. Magnesium plus 2 charge, Cl minus 1 charge. Swap it. This becomes MgCl2. Aluminium oxide also we have seen. AlO plus 3 plus 2 becomes 3 becomes 2. It becomes Al2. Sodium nitrate. Sodium plus 1 charge, nitrate minus 1 charge. This becomes Na, NO3 with the braces, 1 here. But since it is just 1, you can actually remove the braces. Calcium hydroxide, calcium OH minus 1 plus 2. This becomes 1, this becomes 2. This is calcium. OH is a polyatomic ion, CaOH2. Similarly, sodium carbonate. Sodium carbonate, NaCO3, Na with a plus charge, CO3 is a minus 2 charge. This becomes 1, this becomes 2, this becomes Na2, CO3, the braces. Since it is 1 here, you can remove the braces. Okay, then ammonium sulfate, NH4, NSO4. This is minus 2, this is plus 1. This becomes 2, this becomes 1, this becomes NH4, 2, SO4. Since SO4 is 1 here, you can remove the braces from SO4, but you cannot remove it from NH4. Please note that this has to be in the braces. For example, COOH2, it has to be like this. You can't write COOH2. This is wrong. This is right. You should have this bracket. Right? In this case, if you see, both are multi-ion. Ammonia is multi-ion, SO4 is multi-ion. Both ammonia and sulfate are multi-ions. But for sulfate, since it has one, we didn't write the braces. We actually remove it out. But for ammonia, since it is more than one, the bracket is required. Here also, OH bracket is must. Okay. We can also take aluminum sulfate. One example. Let's write here. Aluminum sulfate. So aluminum is plus 3, sulfate is minus 2. This becomes Al2SO4. Please note, there is a bracket here. So we are following all the rules. First rule, the charge is balanced. This is the charge is balanced with this convention. The metals are written first. Yes, the metal is written first in all the case. We are writing metal first. Right? Also, if you see the name also, first you will have metal. And the third rule for the polyatomic, yes, in case we have polyatomic ion, we are making sure it is in the bracket if it is more than 1. Okay. Let's take some more numericals to clarify our concepts. You have to write down the formula of sodium oxide, aluminum chloride, sodium sulfide, magnesium hydroxide. Let's write for sodium oxide, sodium and oxygen. Sodium is metal, oxygen is non-metal, sodium is written first. Let's do the valency balance. Sodium is plus 1, oxygen is minus 2. So this becomes 2, this becomes 1. This is Na2O. That is the formula. Let's do for aluminum chloride. Aluminum is metal, chlorine is non-metal. Aluminum is written first, chlorine is written second. Aluminum has a charge of plus 3, chlorine has a charge of minus 1. Let's do a balance. This becomes 1, this becomes 3. You get AlCl3. Then we have sodium sulfide. We have sodium, we have sulfur, sodium with a plus 1 charge, sulfur with a minus 2, sodium is metal, written first, sulfur is non-metal, written next. Let's do the charge balance. You get Na2S. Magnesium hydroxide. Magnesium is metal, hydroxide OH. Let's put the braces here only. Charge balance plus 2 minus 1. So what you get is MgOH. Pretty easy. Let's take some more examples. Let's write down the names of these compounds. Al2SO43. We just wrote the chemical formula for this. And this is Al is aluminium. And SO4 is sulfate. So you can just write aluminium sulfate. All these numbers you need not worry about. These are all taken care by valency. Ca is calcium and Cl2 is chloride. Right? You need not worry about these numbers. Right? K is what? Potassium. And why we are not worried about these numbers? Because these numbers have been taken care by valency. And SO4 is again sulfate. Here again, NO3 is again a polyatomic ion. K is potassium again. And NO3 is nitrate. So it is potassium nitrate. CaCO3. Again, CO3 is again a polyatomic ion. C is calcium. And this is carbonate. So the only challenge here is to understand which is polyatomic ion in case it is one and the basis is removed. That is the only tough scenario. Else, if the basis is there, you can actually know this is aluminum, this is sulfate, this is calcium, this is chloride, this is potassium, this is sulfate. But in these last two cases, nitrate and carbonate, right, that thing was not given. Okay, the charge, I mean the bracket was not there, so it was a little difficult to understand. This is with experience, with practice, that NO3 is again a polyatomic ion and CO3 is also a polyatomic ion. Don't write the name as calcium, carbon, oxygen. Okay, you have to understand that CO3 is a polyatomic ion. So the polyatomic ion is CO3, 2 minus NO3, 1 minus SO4, 2 minus OH, 1 minus. Anything else I could think of? Yeah, mostly you'll see these kind of polyatomic ion. Okay. What is meant by chemical formula? See, chemical formula we just told is a symbolic representation of its composition. Symbolic representation of composition. Right? For example, water is H2O, sulfuric acid is H2SO4, methane is CH4. So it will tell you what is the actual composition. Right? It shows the constituent elements and the number of atoms also. Right? Numbers of atom of each combining element. For example, here 2 hydrogen atom, 1 oxygen atom. Right? Calcium carbonate, 1 calcium, 1 carbon, 3 oxygen. Al2SO4 3, 2 aluminium and 3 sulfate. HCl, 1 hydrogen, 1 chlorine. So chemical formula actually is a symbolic representation of its composition. So these 4 words are pretty important. Symbolic representation of composition of a given molecule. How many atoms are present in H2S molecules and PO4 3 ion? See, H2S, sulfur has 2 hands in this case, and 2 hydrogen atoms are bonded. So if you see here, there are 1, 2, 3 atoms. So 3 atoms in H2S molecule. Please note, this is H2S is a molecule, hydrogen, sulfur, hydrogen, these are atoms. PO4 3 minus. So if you see here, I'm not sure about the bond, so since you don't know about double bond and single bond, so I've not represented that. Just see 1, 2, 3, 4, 5 atoms in phosphorus. So it will be 5 atoms in PO4 3 minus ion. Note that this is ion. PO4 3 minus, whole thing is ion. Okay, this is also a polyatomic ion. Example is S3PO4. Okay, I think in this case 1 is double bond. I'm not very sure on this, yeah, but I think 1 is double bond, others are all single bond. Yeah, because phosphorus has typically 5 hands, 5 valency, 1, 2, 3, 4, 5, yeah. Okay. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attend free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching. Hello friends, this video on Atom and Molecules part 11 is brought to you by examfear.com. No more fear from exam. So till now we have seen the molecular mass of atoms. For example, we know the molecular mass of hydrogen, carbon, oxygen. These things we know, right? These are all in units. But most of the things around us is compound. For example, water, carbon dioxide, sulfuric acid, ammonia gas, methane gas. All these are compounds. And we want to find the mass, molecular mass of compounds. So let's try to find water. Water has two hydrogen and one oxygen. What is the molecular mass of one hydrogen? 1 unit. What is the molecular mass of one oxygen? 16 units. So total you will see 2 plus 16 is 18 units. Pretty easy, right? So with this you can find the molecular mass of water. Just now we have studied, see, we know the molecular mass of all these atoms. We know that with the formula, chemical formula, the chemical formula actually tells the constituents of this particular molecule, the number of atoms it has. So if I know the mass of hydrogen, mass of oxygen, I can actually find the mass of whole water. See, it is just like that. If I know mass or weight of all the students in the class, let's suppose there are 5 students in the class, student A, B, C, D. Student A is a girl with 30 kg weight, B is again a girl with 35 kg weight, C is a boy with 40 kg weight, D is a little fat boy with 45 kg weight, and E is very fat guy with 50 kg weight, let's suppose. Small class, maybe 5th or 6th. I want to find the total weight of the class. I have to just sum these, that's all. You add all these, 90 plus 35, 135, 170, 200. 200 is the total weight of the class. Similarly, if I know the weight of all these atoms, I can easily find the weight of this whole molecule, because we know that one molecule is composed of these many atoms. Let's take some more examples. Let's take nitric acid. I want to find the weight of nitric acid. So nitric acid has 1 hydrogen plus 1 nitrogen plus 3 oxygen. So let's add this. 1 hydrogen is 1, 1 nitrogen is 14, 3 oxygen is 16 into 3, 3 into 16. So how much you get? 63 unit. Okay. Pretty easy. So let's take some more examples. In fact, this is what we have done now. Relative molecular mass of water and nitric acid we just found. For water it was 1 hydrogen, 2 hydrogen, so 2 into 1 plus 1 oxygen, 1 into 16, 18 units. And for nitric acid we just found 1 hydrogen, 1 nitrogen, 3 oxygen. So 1 hydrogen is what? 1 into 1. 1 nitrogen is what? 1 into 14. Oxygen is 16. You add it, 48 plus 14 plus 3, 63. Okay. So that let's talk about a term called formula unit mass, same as the molecular mass for a compound, just a new name given. Formula unit mass of a substance is nothing but the sum of atomic mass of all the atoms in the formula. For example, I have the formula of H2O. This formula, whatever atoms you have, you add all the atomic mass, that becomes the formula unit mass. Okay. Typically, formula unit mass, this term is used for ionic compounds. Example, you have, let's suppose, PO4 3-. Want to find the mass of this. Okay. Or let's suppose, NaCl. Yeah, NaCl is ionic compound, I want to find the formula unit mass. So that is 1 sodium plus 1 chlorine. 1 sodium is what? 23. 1 chlorine is what? 35.5. You add it, 58.5. Okay, so it's just a new term. Thus now we found that the value of formula unit mass for NaCl 23 and this is 35.5. Add this 58.5 unit. Let's find for calcium chloride CaCl2. This is also ionic, so we'll use the term formula mass for this as well. So it has 1 calcium plus 2 chlorine. So this 40 plus 2 into 35.5. That is 40 plus 71, that is 111 unit. Okay, let's take some questions. We have to find the molecular mass of these compounds. They are all compounds. Hydrogen, 2 hydrogen, 2 into 1, 2 unit. Let's do some here only. Oxygen, 2 oxygen, 2 into 16, 32 units. Chlorine, 2 chlorine atoms, 2 into 35.5, that is 71 units. You can just use this letter or you can write it. Then we have CO2, 1 carbon plus 2 oxygen. Carbon is what? How much? 12 units. 2 oxygen is how many units? 16 units. Solvent 32 plus 12, 44 units. Methane, CH4, 1 carbon plus 4 hydrogen. 1 carbon is what? 1 into 12. 4 hydrogen is what? 4 into 1. 1 hydrogen each is 1 unit. We solve this, 12 plus 4, 16 unit. Done. C2H6, 2 carbon plus 6 hydrogen. 2 into 1 carbon each is 12 unit. 6 into 1. And you solve this, you get 24 plus 6, 30 unit. Okay. C2H4, 2 carbon plus 4 hydrogen. Solve this, 2 into 12 plus 4 into 1, 28 unit. NH3, nitrogen is 14, hydrogen 3, 14 plus 3 is 17 unit. Similarly, CH3OH, last one, has 1 carbon, 4 hydrogen and 1 oxygen. So let's put the value. 1 carbon is 12, 4 hydrogen is 4 into 1, 4, 1 oxygen is 16. 16 plus 4, 20 plus 30, 32 unit. So you can easily find the molecular mass of all these compounds. Let's take one more numerical. We have to find the formula unit mass for ZnO, Na2O, K2CO3. See, formula unit mass is used because these are all ionic compounds. It's also given the atomic mass of zinc, sodium, potassium, carbon and oxygen. Pretty easy then, right? So let's find ZnO first. It has 1 zinc, 1 oxygen. 1 zinc is how much? 65 plus 1 oxygen, how much? 16. To add this, you get 81 unit. Let's take second, Na2O, 2 sodium, 1 oxygen. Sodium is how much? How many? 23. So 2 into 23 because there are 2 sodium units plus 1 into oxygen. Oxygen is 16 unit. So you solve this, 46 plus 16, 62 units. K2CO3, 2 potassium, 1 carbon, 3 oxygen. Right? 2 potassium, 1 carbon, 3 oxygen. Let's put the values. 2 into potassium is 39 plus 1 into carbon is 12 plus 3 into oxygen is 16. Solve this, 48 plus 1260 plus 78, 138 unit. And that is the answer. Pretty easy. Okay. So having understood the molecular mass, let's understand the mole concept now. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.